To my channel Learn Came First. Today's presentation is Electron Configuration. Presentation is made with the help of all necessary rules, diagrams and illustrations to make it easy to understand. Enjoy learning chemistry. Electron configuration is a presentation of distribution of electrons in different atomic orbitals. Besides concept of energy levels and knowledge of different orbitals, it is necessary to have a good knowledge of aforesaid three rules. Aufbau's principle illustrates the atom building of an element. The concept of available vacant lowest energy orbitals in the ground state is mentioned in this rule. Sometimes along with this, an additional concept is required which is delivered as N plus L rule. In continuation of Aufbau's principle, a diagram is inserted here showing the order of entrance of electrons in orbitals of subcells with increasing energy. The essence of Pauli exclusion principle is that no two electrons in an atom can have identical set of all the four quantum numbers. Helium is the simplest element to illustrate this principle. It shows that both the electrons having first three quantum numbers same, but they differ in spin quantum number. In this rule, electrons enter into orbitals of a subcell. They remain unpaired until all the orbitals are having one electron each with parallel spin, then spin paired. In the example nitrogen, the p orbitals are all unpaired having parallel spin. S orbital is spherical having uniform density all through, so no directional characteristics. P orbitals having directional characteristics because px, py and pz orbitals along the x-axis, y-axis and z-axis respectively. These are images of 5D orbitals, dxy, dxz and dyz. The lobes are in xy plane, xz plane and yz plane respectively. In dx square minus y square, the lobes are along the x and y axis. In dz square, the lobe is along the z axis and a ring at the center passing through x and y axis. As per old concept K, L, M, N, which is nothing but n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. The energy of energy levels are E1, E2, E3, E4, etc. How much electron can be accommodated in different energy levels are calculated by using the formula 2n square. Here it is shown how many orbitals are present in different subcells along with their electron accommodating capacities. Electron configuration of simple elements are shown here with the help of box diagram. The significance of representation characters are further shown with a specific example of helium configuration. Transition metals are also known as D-block elements. Here only to discuss first row transition metals, that is 3D. Starting from scandium to zinc. The first row transition metals are extremely important in our daily life. Here configuration is shown with discrepancies of chromium and copper configurations. It is necessary to learn the electron configuration of ions, both cations and anions. Electron configuration of some of the transition metal ions are discussed here. Diamagnetic or paramagnetic properties of the ions are also discussed. Students are advised to do some homework without taking help from others. After this, you visit the website and check it with the answers in question and answers page. Thanks for watching this video. Please subscribe the channel Learn Chem Fast. If you like this video, give a thumbs up. Next video is atomic spectra of hydrogen.